Okay, here's our example. This is going to be showing how to do Gauss-Jordan elimination or matrix row operations, and to do it by hand. This is section 4-3, example number 2. And what we want to do is solve the following system of equations right here using the Gauss-Jordan elimination on a matrix, which is just row operations on a matrix. So when you're solving a system of equations like this using a matrix, you got to convert this system into your augmented matrix. So you need a 3-row by 4-column matrix, and you just write down the coefficients: 2, 3, and 1, minus 2, 1, and minus 3, 1, minus 1, and 2, and then 3, 7, 0. So that's our augmented matrix, and it's a representation of this system of equations. In fact, it's just a different way of writing a system of equations. These two formats here are basically the same thing. And in order to solve this matrix, what we want to do is use row operations to try to get from this set here to something that looks like that. And the way we're going to do it is just go work it column by column. We're going to start in the upper left, and we're going to try to get a 1 in using row operations in the upper left, and then use that to get zeros in column 1 and the 2 rows below it. As you're doing these row operations, of course, you have to keep track of all the values in the other columns. But so these numbers out here on the right are going to change as we go through doing the row operations. You need to keep them straight, but you don't care. I mean, as long as you keep the numbers straight, you don't care what they are until you get to those columns. So start off, get 1, 0, 0 in column 1. Once you do that, then you start attacking column 2, and column 2, you want to go diagonally down this matrix, getting 1s in the diagonals and 0s everywhere else. So when you go to row 2, you go to column 2 and you try to get a 1 there. Use that to get 0s in the rows above and below it, and then just keep working your way down. So let's go through and actually do that. Here's what our original augmented matrix is, and I need to get a 1 in the upper left-hand corner. Okay, and to do that, the easiest way to do that would be to just, with this matrix, is to swap rows 1 and 3. That's unallowable row operations. Okay, and that gets us a 1 in the upper left-hand corner. And so that's what I'm going to do for this one. If you don't have a 1 in one of the rows in column 1 in your original matrix, let's say this number down here that's a 1 in row 3 was a 5, for example. The way you would do it is just divide row 1 by whatever the number is in the upper left-hand corner. So, I mean, I could get a 1 in that spot right there by dividing row 1 by 2. And I would get, dividing this by 2, it would be a 1 there, it would be a minus 1 there, a half, and 3 halves. And so whatever it takes to get a 1 in the upper left-hand corner, do it. So I'm going to do it by swapping row 1 and row 3, and that's all I've done here. And if you look at it, you know, row 1 is now row 3 is now row 1, and row 2 didn't change. So I got my 1 in the upper left-hand corner. So now that we've got the 1 in the upper left-hand corner, I want to use that value to get zeros in row 2 and row 3 in column 1. Okay? And to do that, I have to take, to turn this number from a 3 into a 0, I have to subtract 3 times row 1 from row 2, and then do that all the way across, and that'll replace row 2. That's an allowable row operation. So to get a 0 in row 2, column 1, we multiply row 1 by minus 3 and add it to row 2. You can do that in your head after you get some practice doing it, but as we well know, that can be prone to error. I mean, if you don't want to, write it down below it, or if that makes it confusing, just write it down separately. Okay, we need row 1 times minus 3. So minus 3 times row 1 is minus 3 times 1 is minus 3. Minus 3 times minus 3 is 9. minus 3 times 2 is minus 6, and minus 3 times 0 is 0. So right there, minus 3, 9, minus 6, 0 is just minus 3 times row 1. And we want to add that to row 2, so just write down row 2. And then add them up column by column. Minus 3 and 3 is 0, 9 and 1 is 10, minus 6 and minus 1 is minus 7, and 0 and 7 is 7. So that's your new row 2. Okay, write that down as row 2. And that gets us a 0 in that first entry. To do it with row 3, what you need to do is take minus 2 times row 1 and add it to row 3 to create a new row 3. I don't have that written out separately, but you would do it just the same. You take row 3 and you write it down here. 2 minus 2, 1, and 3. Write it down right there. And then take row 1 times minus 2 and put it here. You would get minus 2, 6, minus 4, and 0. And just add those up column by column, and that'll create a new row 3 for you. And so that's the operations I've done. I took row 2 minus 3 row 1 and put that in row 2. I took row 3 minus 2 times row 1 and I put that in row 3. And that's what we've got here. And that gets us our 1, 0, 0 in column 1. So once I get my 1, 0, 0 in column 1, I start attacking column 2. And I want to get a 1 right here where the 10 is. Okay? And so to make that 10 a 1, I just divide row 2 by 10. Okay? So divide row 2 divided by 10. I get 0, 10 over 10 is 1, minus 7 tenths, and 7 tenths. So that's what this is. That's your new row 2. Okay? If you want, you can use decimals for the last 2 entries instead of fractions. I prefer to use fractions because if this doesn't come out to be a fairly short decimal number, if it was some number like 2/3 or something, you'd have to write down 0.666666 or whatever, to do that. I prefer not to do it. I just prefer to leave them as fractions. But you can do it with whichever way you want, as long as you keep straight in your head that, especially if it's a repeating decimal, that you got to keep it in mind and not allow round off errors to creep in. Okay, so all I did from this matrix to that was row 1 didn't change, row 3 didn't change. I just divided row 2 by 10 to get this 1 right here in row 2, column 2. So now I need to work on getting a 0 in row 1, column 2, and in row 3, column 2. And we're just going to repeat what we did with column 1. We're going to use this 1 here that's in row 2, column 2 to make the minus 3 a 0 and to make a 4 a 0. So how do I do that? To get a 0 up here, I got to take 3 times row 2 and add it to row 1 and then use that for my new row 1. So I write down row 1 and then write down 3 times row 2. So 3 times 0 is 0, 3 times 1 is 3, 3 times minus 7 tenths is minus 21 tenths, and 3 times 7 tenths is 21 tenths. So that's, right here is 3 times row 2, and right here is row 1. You just add them up. 1 minus 3 and 3 is 0. 2 is 20 tenths minus 21 tenths. It leaves you with minus 1 tenth. And then 0 plus 21 tenths is 21 tenths. So write that down in row 1. And we're going to do the same thing to get a 0 here where the 4 is in row 3, column 2. Just going to take minus 4 times this, times row 2, and add it to row 3. So down here you could write down what row 3 is. 0, 4, minus 3, and 3. And then take minus 4 times row 2 and write that down here. So you would get 0 times minus 4 is 0. You get minus 4 there. You'd get 28 tenths and minus 28 tenths. And then write those down and just add them up to get a new row 3. And that's what I've done here. Okay, so I took 3 times row 2 and added it to row 1. And I took minus 4 times row 2 and added it to row 3. to make the new row 1 and to make the new row 3. And row 2 didn't change. So now I've gotten 1, 0, 0 in column 1. I got my 0, 1, 0 in column 2. So now I'm ready to start working on column 3. So there's my previous slide. I need to get a 1 down here. I'm working my way diagonally down this matrix, and I want to get a 1 here. Okay, how do I do that? We need to multiply row 3 by minus 10 over 2, and that'll make that a 1. Or minus 5 is the same as minus 10 over 2. So row 3 times minus 10 over 2. Minus 10 over 2 times 0 is 0. Also there. Minus 10 over 2 times minus 2 over 10 gives me a 1. And minus 10 over 2 times 2 over 10 gives me a minus 1. Okay, so that's my new row 3. 0, 0, 1, minus 1. Just write that down in row 3. We're not going to change row 1 and 2 at this point. So 3 times minus 10 over 2, go and put that into row 3, gives us that. That's the only change I made, and we can already see part of our solution developing. And now what we do is we use this 1 here down in row 3, column 3, to make the two numbers above it both be 0. So we're just repeating what we did with column 1 and column 2. Okay, to get a 0 up here in row 1, column 1, I got to take a tenth of row 3 and add it to row 1. Okay, so I want to take a tenth of row 3, add it to row 1. So just we'll row 1 down, and then write down row 3 times a tenth, or row 3 divided by 10. It both means the same thing. So I get 0, 0, a tenth, and minus a tenth. And then, again, just add those up. I get 1, 0, minus a tenth, and a tenth is 0. That's what I was trying to do. And 21 tenths minus a tenth is 20 tenths, which is 2. And just write that down in row 1. That's your new row 1. 1, 0, 0, 2. To do the same thing for row 2, I need to turn this minus 7 tenths into a 0, so I just take 7 tenths of row 3 and add it to row 2. Okay, and that becomes my new row 2. So 7 tenths times 1 is 7 tenths. Added to minus 7 tenths, I get a 0 here. And minus 1 times 7 tenths is 7 tenths. Added to 7 tenths, I get a 0 there. So my new row 2 is going to be 0, 1, 0, 0. Okay, and again, if you don't want to do that in your head, write down row 2, write down 7 tenths times row 3, and add them up column by column. Again, as I said before, you got to keep all this arithmetic here that you're doing straight. The multiplying the rows by a number and adding them up column by column. If you don't, it's going to throw your answer off. So take it step by step. Do it one step at a time if you need to. So those are the operations I performed. I took row 1 plus a tenth of row 3 and put it in row 1. I took a row 2 plus 7 tenths of row 3 and put it in row 2. And here's what I ended up with. And so now I've got my 1s in the diagonal. Everything else is 0 on this side. And the values that are left over in the right are 2, 0, and 1. And that's my solution. Okay. So the final answer is x equals 2, y equals 0, and z equals minus 1. Okay, and you can take those numbers and plug them back into your original 3 equations to check to make sure that it's correct. Okay, the other thing you can do is run it through RF on your calculator to make sure that that's the answer, the same answer the calculator gets. Okay, if while you're doing row operations, one of these steps that you're doing, you get a row that's got all zeros in it except for the right-hand column. You get 0, 0, 0, and then something that's not 0, stop. Okay? If you get that, the system of equations is inconsistent. There's no solution to it. So if you're doing that on a homework, just pick the option that says inconsistent. If you're doing that on a test, write down system is inconsistent, no solution. Okay, You might want to double check and make sure you got your arithmetic right getting to that point. But if you get a row like that and you did it by doing valid operations, there's no way to fix that. There's no way to make any of these things not zero. So there's no way to solve that system. If, as you're doing this, you get a row that's all zeros, 0, 0, 0, 0 across, then just move that row to the bottom by swapping it with whatever's on the bottom. Just put that row of all zeros at the bottom. Okay, what that's going to mean is that the system of equations is going to be dependent, and you got to figure out the dependency. And what you do is you get what's left of the matrix, the upper left-hand corner of what's left of the matrix, to be 1, 0, 0, 1. Let's go back and look at the previous slide. Okay, if this bottom row, if somewhere along the line I had gotten all zeros in here, I would have moved that to the bottom row. With the bottom row all zeros, these two values up here above it probably would not be zeros. So if you get a row of all zeros, what you do is you just kind of you just attack the upper left-hand corner to get 1, 0, 0, 1. You're going to probably be left with non-zero values here and non-zero values here, and that's just going to be your dependency. Okay, that's how you figure out what the dependency is. So if you're doing that, you get a row of all zeros, just move it to the bottom by swapping it with whatever the row is on the bottom, and just keep working your matrix, except you're just going to have to get the upper left-hand corner to be 1, 0, 0, 1 instead of all the way down the diagonal. So that's how you do row operations to solve a system of linear equations.